My name is Matt Shinsky. I am our energy market manager, and I'm also a principal associate in our firm. We will be presenting along with my colleague Pat Van Haverbeck, who is a PLS and a senior associate in our firm. We will be going over our aerial LiDAR process for pipeline projects. So today's topics that we'll be reviewing will be LiDAR. We'll give you a thorough overview of what LiDAR is. And we'll also be discussing the benefits of utilizing aerial LiDAR for pipeline routing. And then notice to proceed to delivery, the life cycle, and we're giving an in-depth review of the life cycle of an aerial LiDAR project. With that said, I'm going to turn it over to Pat Van Haverbeck.
Thanks, Matt. So my name is Pat Van Haverbeck. I am a licensed surveyor in a handful of states here with Maser Consulting. And I also hold a master's degree in surveying engineering from the University of Maine. For the last several years, my survey career has kind of taken an interesting turn, and I handle mostly aerial LiDAR projects for the company. So I guess we'll start with a definition of LiDAR. LiDAR is an acronym for light detection and ranging. It is similar to sonar in that sense, and also in the sense that this is an active measurement system. The LiDAR sensor actually sends out a pulse of light energy and records time of flight between when the pulse leaves the sensor and comes back. In order to make this a survey grade technology, there's actually several components that work together. First is the laser scanner that actually sends out the pulse of light. The inertial measurement unit, or IMU, records the roll, pitch, and yaw of the aircraft as it's traveling in the air in order to correct for the location of the sensor at any given time. And the GNSS receiver, which also works with the IMU to record the X, Y, and Z position of the sensor. There's a couple of different strategies we have depending on the project. The UAS LiDAR platform, what you see there is the Vapor 55. We have 3 LiDAR sensors that can be carried by the Vapor 55, and we cover anywhere in the continental USA with those 3 sensors. The advantages of the UAS based collection procedure is that the aircraft flies slower and lower than a manned aircraft would, and that gives us a denser point cloud and gives us better vegetation penetration. So the general rule of thumb is unless we have to use UAS, anything more than 10 miles or so, we try to use manned aircraft. It just makes more sense from an efficiency standpoint to use the manned aircraft at that point. Exceptions to that would be if a project needed to be flown during the summertime when the leaves were on the trees, then we would definitely try to use the UAS-based platform. The manned LiDAR platforms include the fixed-winged aircraft or rotary wing aircraft, helicopters. They tend to fly higher and faster, but they are advantageous in the sense that they can cover more ground, so they're better for larger projects. And they can carry the heavy LiDAR sensor and RGB, or just a regular camera, at the same time, so they can dual collect the LiDAR and photo data all at once. Some of the basic components. This is our Vapor 55. The IMU you see is fastened to the back of the actual LiDAR sensor. That is working in conjunction with the GNSS receiver on the top. All of the offsets are measured to the LiDAR sensor itself. That is what we care about at any given moment in time, where that LiDAR sensor is when it sends out that pulse of light. And in the post-processing procedure, we always compare the data collected on the helicopter to static GPS data that's collected simultaneously on the ground. So this is just a little example of how it all comes together. The helicopter is flying at the elevation, collecting data, sending out pulses of light. As it's flying, it is collecting the X, Y, and Z location of where that sensor is. The IMU helps correct for the roll, pitch, and yaw, takes out any bumpiness due to wind conditions or anything like that. And then after the helicopter lands, we download that data and we post-process it, comparing it to the known position of the GPS receiver on the ground. And that, from that, we export what's called the trajectory. The trajectory is basically the spine of the data set. It is the known X, Y, and Z location of the sensor at any given moment of time. And from that, the actual laser data become the ribs. It's tied to that trajectory via a timestamp. We know where that sensor was at any given moment of time, and we kind of just hang the laser data off of that in order to come up with our final point cloud. So how can LiDAR help for the pipeline routing process? There's a lot of reasons. Probably the one of the most obvious is efficiency. We can collect a lot of data in a hurry. If you think about a conventional survey crew, they're out there setting traverse points, cutting line through the woods to record topographic information. This, once we have it controlled, we can fly it in hours and have data processed and mapped and back to a client in weeks. The second advantage of LiDAR, and this one is more in comparison to photogrammetry, is that we can penetrate tree canopy. If you are solely trying to use aerial photogrammetry to do these projects, if we can't see the ground in the photos, we can't extract ground data. LiDAR is an active measurement system, whereas it's actually sending out pulses of light, and those pulses of light provide multiple returns to the sensor, starting from the top of the tree, the canopy, and then filtering on down through all the way to the last return, which is typically your ground surface. So even during full leaf-on conditions, in most cases, we can still provide data sufficient to generate 1-foot contours. So large areas, we're talking about the field crew being out there, you know, in tough wooded areas, we're going to be talking about hundreds of feet they can gather efficiently a day. Whereas we can fly this a whole, you know, 30-mile corridor in hours and do all of the extraction and mapping on the back end. There's a safety concern there. A lot of gas pipelines are through mountainous terrain, typically don't have cell phone communications. You put survey crews out there, they're kind of out of, they're not reachable for large portions of the day. They're dealing with difficult terrain, four-wheelers which can flip over. It's a dangerous job. Most of them love doing it, but if we don't have to put them out there in harm's way, we don't want to. Unobtrusive data capture. So a lot of times, for the same reasons that we don't want to put field crews out there, there are landowners that are less than happy that there is going to be a pipeline going through in their backyard. We can fly those. Nobody even knows we're there. We're in, out, we have the data we need, and the design process can move forward, and we can determine if this is even a feasible corridor before we have to start negotiating with landowners. Higher accuracy, that's in the sense that we're not missing anything. We can always go back into our our data files and verify, this is a strange looking ditch. Is this really what it looks like? We can open up the point cloud. We can take a look and say, yep, here it is. This is definitely what it looks like in the field. Another aspect of that is it's not subject to a surveyor's interpretation on the ground. A lot of times when we're out there collecting 50-foot grids, we miss bends in the stream. It's just the nature of the job. But this technology actually captures existing field conditions exactly as they were at the time of the flight. The last bullet point there, robust data sets. We can do a lot with this. We can pull out tree heights. We can give you building locations, wire sags. We can extract contours, obviously. Go back and contain these data sets throughout the lifespan of a project and provide different deliverables as needed. So I mentioned before the manned aircraft that has the ability to carry both the RGB and the LiDAR sensor simultaneously. Case in point here, why that is advantageous is things often change pretty quickly out there. I know a lot of companies use Google Earth for planning, but like I said, things can change quickly as this slide shows. On the left, we have Google Earth, and which sometimes is not updated for years. And then just coincidentally, when we flew this particular project, some of that subdivision has already been built. So that's good to know when you're contemplating where to put a gas pipeline through. So some of our different output options, there's numerous. We will work with any company before a project starts and come to a consensus as to what deliverables will work best. We're very flexible. We have provided everything from just a point cloud, for some companies that can do their own extraction, all the way up to finished planimetric and 3D modeling, contours. Change detection is noted there. That works pretty well for like vegetation encroachment. We can fly a given site numerous times, once a year, for example, and compare the point clouds year to year to see where vegetation has started to grow into the corridor, or where they've built new houses, where encroachments might be popping up, stuff of that nature. So real quick, we recently did a project for a client who came to us with a 29-mile proposed corridor that was partially opened, partially they had the easement set up, but the right-of-way hadn't been cleared yet. It was a very time-sensitive project due to some of the funding that was tied to it. It was in hilly terrain, so they were concerned about the time span of sending actual boots on the ground surveyors out. It was in the middle of nowhere, and they already knew based on some previous dealings that they had some uncooperative landowners out there. So they didn't want to, poke a stick in the hornet's nest if they didn't have to. And they kind of asked us if there was an approach that we could think of that could get them the design quality that they needed to figure out if this was a buildable project in a short period of time. So once we came to a consensus on the approach and were given notice to proceed, it was just a matter of days before we had a field crew out there on site painting targets on the ground. I should mention that this one was 29 miles in length. So we decided, given the hilly terrain and the length of it, that a manned aircraft approach would be best. So we partnered up with a company to collect that data. Once we had the the targets placed and surveyed on the ground, we notified the pilots that they were clear to fly. And on the next available good weather day with no snow, no wind, no clouds, stuff like that, they got out there and collected the data for us all in one shot. This was a LiDAR and photogrammetry project. So we collected the LiDAR to create the surface from, but also the photogrammetry to aid in the LiDAR extraction, and so the client could see what they were dealing with as far as buildings, etc. out there. So January 23rd, we had the project flown. From there, behind the scenes, all of the data was adjusted, processed, mapped, and we had all 29 miles extracted, mapped, and delivered by February 26th, just a month later. So this is that same project. I'm going to kind of use this one area from that project to walk through the 30,000-foot view of how the processing goes. The white line that you see there is the project corridor. The pipeline is in the center of that, and I believe for this one we extracted 250 feet on each side for a total width of 500 feet through the proposed corridor. So we take the registered point cloud, and we have a bunch of different softwares that we use together. The first step, I guess, is to take the point cloud and classify it to what is called ground. It takes out all of the green there. You see that's the trees. The yellow is buildings. It removes all of that stuff and gives us what is this, your bare earth. Those white areas where the buildings were, there's actually no points there. What we're looking at here is what you would see if you stepped outside and all the trees and buildings and grass and everything just disappeared and you were looking at nothing but bare earth. So once we have that bare earth model, we actually go through and use a combination of software and physical CAD extraction and create all of the model key points and break lines that would normally go into any survey surface. This is the same procedure as if we had boots on the ground approach and had field crews out there collecting data. We were just doing it from the safety of behind a desk in a controlled environment and much more efficiently. Here's a little bit tighter view there. So the green points are all of the 3D model points. Those are similar to the spot shots that the surveyor would collect out there, but you can see that they're a lot more dense than you would normally expect from a field gathered project, which just makes them a little bit more accurate. We're collecting a truer representation of what the Earth's surface looks like. The blue and magenta hatched areas are areas where we actually go through and pull out, create break lines so that when we're doing the creation of the surface, we're not missing small features like ditches that might fall between the key model points. So from there, it just basically becomes like any other topographic survey. We bring the model points and the break lines together to create the triangulated irregular network, or TIN model. This here is a little bit tighter view, and this is what the surface is created from. You can see we trim out around the buildings and all that stuff just like a conventional survey would do. Once we get that surface put together, we can use that to create the visual representation, in this case in the form of 1 foot contours. I think this is a 5 foot index. The red lines occur every 5 feet. The white lines are 1 foot contours. Here's a little tighter view of that. You can see on the west side of the road there, the contours flowing up along the ditch. The roadway crown looks good. Contours are all trimmed out around the buildings. This is exactly what you'd expect to see from a boots on the ground approach as well. So to kind of bring it all together, safety, this approach is a lot more safe. We don't have guys on the ground out of contact without cell phone service in hostile or difficult terrain. It's faster for larger projects. We can collect data more efficiently. It's more accurate in the sense that we're getting every little bump and cranny. We're not missing anything. It's an unobtrusive process. The landowners are not usually even aware that we're out there. We don't have to knock on doors and ask permission to navigate through people's properties, etc. The data set, we can provide multiple deliverables from that. You know, we've done stuff for clients and where, you know, we've provided, you know, up to a half a dozen different deliverables over the lifespan of a project, and we never have to step out in the field again. It's been great. Which brings me into the next point. There's a huge reduction of return visits to the site. If anything doesn't look right in the mapping, or if we decide we need something else extracted, we have it right there in the can, we call it. We don't have to send people back out into the field to double check things. And especially on the UAS side, we can collect these projects year round. We don't have to, we're not stuck in the winter aerial data collection cycle here in the eastern and western parts of the country because of the tree vegetation. And I guess that about does it. From there, Matt and I both can answer any questions that anybody might has. And I think, Maria, you're going to jump in and kind of read anything that's popped up.
Yes. Thank you, Pat, and thank you, Matt, as well. We have a few questions. The first question is from Sean, and he asked, can you explain how the limitations of the line of sight affects field operations?
Sure. So that only affects things on the UAS side. The FAA requires that we maintain line of sight of the aircraft, but it doesn't really slow us down. We have found that mostly, you know, by placing our landing zones just right, we're able to maintain line of sight in all but the most hilly of terrains. It's really on a project by project, case by case basis, but if we have to bring in the manned aircraft to do that, it's because of, you know, hills or line of sight obstructions. That's not a problem.
Okay, thank you. Another question. This question is from John, and he asked, can you explain the difference in accuracy between UAS and airborne LiDAR?
So generally, the accuracy is similar. Where the big difference is in the density. I think I mentioned because we're flying so much slower and lower, we're getting upwards of 100 points per square meter. You know, usually many more than that. Whereas in the manned aircraft world, we typically don't promise more than 20 points per square meter. And that's not just on the ground, that's the whole column on the way down from tree top to ground, you know, 20 points in that square meter. So we're able to pick out much more detail. We're able to fly when leaves are on the trees and still have sufficient data getting through to the ground to produce 1 foot contours.
Okay, thank you. A couple more we have here. This question is from Dave, and he asked, what is the wavelength of the light you use?
So it really depends on the sensor. Each sensor is a little bit different. You want to get get in touch with us offline. If there's a sensor you're looking at, we can address that.
Okay. This is a question from Leo, and he asked, do you feel that collecting the data using LiDAR is more accurate versus conventional?
So generally with our UAS system, we're at plus or minus 0.08 of a foot, which is an inch. And that's on hard surfaces. That is generally the same results you would expect from an RTK GPS survey. So I would say that we are as accurate, with the advantage of having a lot more data points, so we can also pick up the finer details of any given surface.
Okay, gosh, we have a lot of good questions here. Another question is, this is from Dan, and he asked, can you talk about the value that is added by having licensed surveyors perform and analyze the data as opposed to UAS firms that use the software but are not surveyors?
I love that one. So I have experienced, I've had clients before that have been burned. I wouldn't say burned, but they appreciate the fact that we have licensed surveyors overlooking every aspect of these projects, because we understand that the product that we're delivering is only as good as the control that it's tied to. And without an understanding of how to lay out control and, you know, accurately tie to it, you never know the you can't certify the quality of your product. So that's been a huge advantage of us, even internally, in getting, you know, other surveyors in the company to buy into it. We can speak to, and generally we use the ASPRS accuracy guidelines. We know how to perform the mathematical calculations to tell you exactly how accurate the product that we're providing is. And we can do that all in-house, which makes it really a seamless product experience.
Okay, great. Another question is, when would LiDAR not be advantageous?
So LiDAR doesn't penetrate water. So stream crossings and stuff, we still have to pick up conventionally. Really, the way I look at it and the way I approach projects is, anytime I'm required to provide a 3D deliverable where the Z component is crucial, I am using LiDAR over photogrammetry every time. If you're only looking for planometrics, then LiDAR is overkill. You're better off using a photogrammetric approach. But aside from that, whenever I can, I am using a LiDAR.
Okay. Sorry about that. Okay. Another question is, actually, there'll probably be two parts of this. Do you also collect photo data, and does that photo data help you?
That's a good question. So it really depends on the site. Anytime we're going to be doing planometric extraction, where there's a lot of buildings, roads, stuff like that we're going to have to map, I like to also collect simultaneous photo data, because anybody who's worked with LiDAR data, once you get into it, it's just a bunch of white points, and it's hard to tell the difference between edge of pavement and the shoulder of the road, things of that nature, without the photo-based data. So anytime we're doing a site that is anything more than woods, generally, we are also collecting photo data. It might not always be on the same flight, but we will collect it and process it and use it to help in the extraction process.
Okay, thank you. Another question here is, there They're asking, what do you and the firm see as a future for this technology, and how will it expand?
That is a good question. This technology is really growing by leaps and bounds. It has been for the last 10 to 15 years, probably, but even more so lately since they've figured out how to get them small enough to be mounted onto UAS. The way that I see it, this is going to become more and more a standard approach to performing these projects. I think especially once the FAA opens things up so that we can fly regularly beyond the visual line of sight. But this is not going away. It blows my mind. Now they have dual sensors that can penetrate water. It's two LiDAR sensors in one. One's got the green laser, and one's the traditional that we've been talking about. But in one flight, you can do bathymetric and topographic survey, which is, it's amazing that they have those small enough to fit on a UAS now. But it's not going away. It's only getting better. It's getting more accurate year by year, and it's definitely here to stay.
Okay, thank you. Another question, this is from Dave, and he asks, can you fly over landowner property without permission? What are the rules and the laws about that?
So we follow the FAA guidelines. All of our pilots are 107 certified. We have a couple in-house that have their commercial pilot licenses as well. And the FAA approach is that your property rights go away. There's not a defined height above your house and stuff, but that airspace, it belongs to the United States, and we do not require permission to fly over those areas. Now, there are certain areas around airports, around landmarks where the use of UAS is restricted, and we have to go through procedures with the FAA to get permission to fly in those areas. But as far as landowner rights, that is not something that we usually have to worry about with this technology, especially with the manned aircraft.
Okay. There's another question here we have. Do you have any scope recommendations specific to pipeline corridors for your clients that are not as familiar with the equipment and parameters?
So that's all case by case. It depends on what they need. Do they really need LiDAR? Are they trying to get a surface? Are they just looking at planimetrics? There is no universal answer. It's really a project by project, location by location approach to that sort of thing.
Okay, let me see. Let me just do one more. So the question is here, and I hope I'm reading it accurately, and I apologize if I'm not, but this is from Dave, and he says, no particular sensor he's looking at, but I'm just wondering where on the EM spectrum you are. Is it visible light, UV, or infrared?
Infrared, generally. It's not visible. It's all eye safe. You don't have to worry about people wearing protective glasses or anything. I hope I answered the question.
Okay, great. Yeah. I think that wraps up the questions that I see here. And I know that obviously people can reach out to you, and if they have questions, and you'll communicate back to them as well. So so I will finalize here with the questions, and if you want to wrap it up with the.
Yeah, this is Matt. I would just like to add, thank you all for joining us this afternoon. We certainly appreciate your time and attention. I would like to say in closing that Maser Consulting does provide aerial LiDAR services, not only for pipeline projects, but for other linear projects, including electric transmission distribution projects, DOT projects, We also use this technology quite a bit for land development projects as well. So certainly if you have any of those types of needs or questions that you'd like to discuss with us, you can reach us at the survey webinars at mazerconsulting.com website, and we'd be happy to set up a follow-up meeting with you. But again, thank you for your time. We certainly appreciate it.